So basically, there's also alternatives as a cloud version of it. It's a no-code platform for training and deploying our models. So you can create an account, you will get a $5 free credit, which you can use it for some learning. I You could use this for a quick start, but it's it's good that you actually do it in a programmatic way than doing this cloud no code way. But at least for teaching purpose, it can understand the high level concepts. Okay. So this is the Ultralytics cloud. It's similar to like AWS cloud. There's no code involved in it. Everything is set up for you. Um, so you can explore some public data sets, models. You can even annotate within this platform. You could train your models. You can then deploy your models. Set up some API access keys. That's it. Then the first would be is to explore data sets. So uh, there are like 8 free example data sets that they have shared with us. Data sets. No, I think this data set was created by me. So what I've done is I imported some train 8 images or something like that. And then I have labeled them or probably those labels already. So from this, you could then create a new model, call it Yellow 26 Nano. Select your project. Let's train it for a box. Use auto batch size, or you can also define your batch size like 8. Define your image size. You can also do some advanced configurations, right? Like defining the patients. These are like a little advanced concepts, but they are, we don't have to worry at the beginning. Then it costs you, if you are using a very powerful GPUs, then it costs you like $2 per hour, but probably use low cost GPUs, for example, this is also fine. So I have a $5, so I don't think I might use all of it, but so this is a quick way to start your training, right? So you don't write a single line of code. So some few images, those are labeled. I select the model, and then I started my training. Yeah. Okay. So it is completed. Okay. Now I got an MVP of 90.7%. Okay. Now these are some of my plots. So this is my precision curve. This is my recall curve. This is my MVP curve. Now you can see how my precision changed over the box. And also how my recall changed over my box. How does my loss curves? Then there is confusion matrix. So since it's a very just with 8 images I trained, you do not get a very meaningful confusion matrix. But then this is the precision recall curve that we discussed. So you can see there is uh, one curve for bicycle. It seems to be perfect with precision of 1 and recall of 1. And then we have the purple with 7274%. And then there is other precision recall. So this is basically a precision recall per class actually. So the overall is the blue line. So this one, okay, this is the average. The other colored ones are per class. So similarly for this also. So the thicker one is basically the average one. The thinner colored ones are for per class. So this is how you need to interpret these curves. Okay. So these are all created or generated for you automatically in this cloud platform. Okay. But this is also generated in the when you're running it in the Collab notebook also. Not sure if it is still connected, but so when you run this, it will create one experiment folder here, and all the curves that we see in the cloud will also be generated automatically for you here. Okay. Probably I think it's good to try that. Okay, while it is connecting. Okay, and you could also okay. So you could also upload some example images and predict. Okay. So let's say I want to predict the run inference of this image. So it this is the model prediction outputs, which seems to be pretty accurate. So it was processed in 1.5 milliseconds. Because it's running on some cloud GPUs, it's pretty fast. No, actually the total is about 96 to 100 milliseconds. Out of that, 1.5 is pre-processing, 0.2 is post-processing, and this is basically the actual model inference time it took. Okay, so this is the model output JSON. This is how, and for integration, right, you could just take this code and integrate it into any of your existing product pipelines. You could train here, you could do some predictions on images, you could even upload uh, images from computer. Let's say we can upload this image, and you can see it's predicting pretty accurately. All the cars are predicted, the person is predicted, the handbag is predicted. It's even able to predict a car at a very far distance also. Okay, then so here's where you can export the trained models into different formats. So the most frequently used are the ONX format, OpenVINO format. So let's say if I just export, so you can also say what precision you want. If you want to speed up even further, you can do intake quantization. By default, it runs on half precision, half floating point precision. But if you want to speed it up further, then you can also do intake. But by doing intake quantization, you might lose the accuracy. But you have to see how much accuracy trade-offs you're making. So then the simple click of a button, it can export your model from PyTorch file to a ONX file. Then you can directly deploy this ONX file. You can just download them, which is now 2.9 MB only. Okay, so this is how it get exported. And it supports various other types of export formats. Then you could also deploy directly into Ultralytics Cloud. Then using APIs, you can do inference. Okay. Why they're not bringing the API to people? Let's say by using the API also, what you are trying to transfer the data out to the becomes yeah, it goes through the network. So the model runs on some cloud environment which is managed by Ultralytics. Okay, and your product or any of your whatever the pipeline that you are building can access that Ultralytics deployed model, Ultralytics cloud through APIs. And you need to have some API authentication keys to basically authenticate, hit that endpoints, pass in some images. So what it will happen is it will upload the images from your computer to that Ultralytics cloud, run the inference and get the outputs, and it will give it back to you. So there will be, of course, network latency. Uh, yeah, again, this is just for learning purpose, but it's not a good way to go deeper. The best way is to go at the code level. Okay. So now the training started. Just training it for 5 epochs, right? See, the model architecture for YOLO V8 will have these layers. So it also has a similar convolution. Um, so here it also takes care of the data augmentation also. So there is a library called augmentation, which is a very popular library for data augmentation. Did you guys use this library in your either of deep learning course? So this augmentation library is also integrated. So it also does the basic data augmentation like blurring, uh, all those things. So in your working directory, so the important thing would be is this YAML file. So then basically it creates runs. Runs are nothing but different experiments that you want to try. So it creates folder for every experiment. So since we are doing detection tasks, it creates a folder called detect and put those experiment data within that. So we are training in YOLO V8 nano model uh, and created some folder name automatically. See, now you can see the weights are gets stored in this. So since so whatever we saw in this, right? Uh, yeah. So these all these graphs, the precision curve, recall curve, MAP curve, loss curves, the confusion matrix, the peer curve, F1 curve. All these curves are also will be generated in this code. Yeah, let's wait for it to complete. See, you can do the same thing with Claude. Okay, so this is what it is being heading towards. So I don't know, there are some POCs or there are some sort of a concept that if I upload an image, okay, and I ask the Claude to say what it might give you. Okay, let's try that. I think this is the first time I'm trying Claude. See, it's giving a pretty accurate description. It says there is people. A woman is walking across the zebra crossing wearing a blue t-shirt, jeans, sneakers, carrying a brown crossbody bag. Vehicles, it has a yellow taxi car. It also tells you where it is, foreground left, a dark red maroon hatchback, silver white hatchback. Roads and infrastructure, there is a zebra crossing, there is a multi-lane road, a curb, green metal barriers. It's quite comprehensive and accurate, right? Yeah, this is what is running behind agents. The agent is nothing but this is yeah. So this is where we are trying to see if the VLMs or LLMs are better than YOLO models. Okay, what is the limitation that you see here with YOLO? can I use Claude in my vehicle? We have this vehicle monitoring systems. Can I use Claude there?
You cannot take any action on it.
Hmm. So what it outputs and what YOLO V8 outputs, and can you compare and tell what it is missing? Hmm. Basically, it is giving a scene descriptions. It's very, very good in giving scene descriptions, but I'm not getting the bounding boxes from this, right? But sometimes it gives. Okay. But it says you. Yeah, it is like either jack of all trades and master of none, something like that is there, right? So his ChatGPT is like that. In some fields, it is a master, but it tries to do everything. But can it beat YOLO models? It's still an open question. So far, we are not convinced it can beat YOLO models. You're not convinced, huh? Claude is better, huh? I mean, hey, see, you can't take risk with Claude in some medical diagnosis and all, right? Sometimes it hallucinates. Even the normal cell, it will tell cancerous cell. Uh, Same thing can happen in YOLO V8 also, but at least we understand why YOLO V8 does that. See, here it says the image is of this dimension, correct? Then it says woman is 860, 150, 1180, 800. Okay, but is that correct? I don't think it is correct.
You can ask to generate in Google format so that you can compare.
Yeah. You see, here also you can compare, right? I think our uh, the pedestrian coordinate starts from something like 2000. So the total size is 3500. If it starts from 800, means somewhere towards left, first to 1/3 of the image. But actually the woman is in the far right. Okay, which I think, sorry, I think this is not correct. You can verify it. Huh?
What resolution?
Resolution, it took it correctly because, okay. So if you divide this 4,000 into 3, it will be like 1,200, 1,200. So it says it is in the left first quarter, right? But actually the lady is in the right. So from that itself, common sense, I can say it is wrong. But it is very confidently saying that this.
It's also.
Yeah. So that's why it's little bit unpredictable. So even it itself says this is just estimated bounding box. Okay. For a precise one, use YOLO or detector. So it is also very careful. It's very safe, diplomatic. So that's why whether, but this is the current scenario, but maybe down the line in couple of years or 5 years, it can evolve into a capable model to give a precise bounding box. Right. Age or the objects. Sorry? But it is able to describe. Yeah. The scene description is very perfect, actually. This. So if we say, for example, we're using a model to identify some object in a medical records. If it is able to describe in a very human or natural language, it is even better. Yes, sir. But where there is a need to get the precise bounding box coordinates, then that is where the limitation is. So even, yeah. So if you go to doctor, right? So they will say that hey, here is a fracture. But maybe it will tell you there is a fracture, but it cannot tell you where exactly is. It will just give you a very approximate location. So then they'll put a little bit. Again, it. Oh. You can use something to describe, the objects. Pass the output of that to NLP, it will give a description. So you need to decide for your use case which model is more reliable and accurate. Cocktail. Even open source small models or normal NLP is good enough to describe. There were also image description model before this LLMs came. They were not as detailed, as accurate as this. See the way it is described, right? The previous generation NLP models were not able to achieve this. Or ChatGPT cost optimization. If I can use an open source models, which can do the job, we can use that to do those models. Yeah, okay, I'm seeing where you're getting. So you're saying why should I use this proprietary expensive models? If I want to deploy a private models, I can. So there is a model called Clip, OpenAI Clip. So those are like very breakthrough models before this ChatGPT came. So that is where it's again from OpenAI only. So earlier there used to be two separate worlds. The computer vision images, videos used to be separate. Then the text NLP used to be separate. There is very little commonalities between these two. So that's where this click model came in probably 5 years back. Before just 1.5 year before ChatGPT came, this clip model was a breakthrough model where it was able to combine both images and text. So they were able to train a model combining the images and the image description of that image. Okay, so then you could go from text to image, image to text. So these are all the beginning of that ChatGPT things. Maybe from this only they slowly transition into those LLMs and VLMs. So to answer your questions, for example, if clip is sufficient for your use case, then you can use clip kind of models instead of going for a ChatGPT or a Claude kind of models. So it can also you see the problem, right? Mhm. Yeah, yeah. That's why I said. I don't think it is capable of doing it. Okay, so with this level of performance, I won't be relying this. Change that low to high. Oh, this one now. Okay, okay. Yeah, that's why I chosen a thinking model, which is even more robust than. Yeah, it's kind of. It's not able to do, I think. Hmm? Maybe somebody can try in ChatGPT and. Or somebody has Claude Pro version, Pro subscription. This image, yeah. Image I have already given in this link. Pedestrian.jpg. You don't have the link. Okay. Every model is giving different output, but none of them is correct. Not giving, huh?
Bit closer.
Yes, sir. See, this is the problem. So I don't think we are there to replace an YOLO model with LLM or VLMs. Yeah, somebody can take this as a capstone project, build a VLMs for object detection. And you can just publish paper. You can beat OpenAI. So I was just showing them like, can we do object detection using Claude or ChatGPT? No, that is okay, but it's not even with X, it's not doing it. So it is just throwing some craps. So it is very good in scene description. So if I ask what objects are present in the image, right, it gives you a very excellent description of the image. But then I ask, can you give me the precise bounding box coordinates of all the image in the objects in the image? It gives, but all of them are wrong. Then we ask them to plot it. So it just gives some random boxes. So yeah, so it means that still YOLO models are valid and relevant in all of the industrial inspection use cases and other use cases. So probably currently the model is not capable, but maybe 3 years, 5 years, it might. Yeah. It's like an open area. Better. Is drawing, huh? You can just copy paste that outputs in the team chat, no? Huh? Okay. Ah, this is much better.
Just upload and give that.
Okay, okay.
Something is better.
Then we have to test it with more complex scenarios.
So many cameras now they use object detection. They capture motion, like DSLR cameras itself.
Okay.
They use the same knowledge or more technical.
So they use something called optical flows motion estimation. So to capture the motion you're saying, right?
Even objects, it detects your face or a face when you're happy, sad. It will be able to capture it.
The
It
emotions.
focuses on No, it and blurs the background.
Okay. So the bokeh effect or the portrait effect. Basically, that is image segmentation. So next week we'll see, right? So where we could segment the foreground image from the background. If we could do that, then we could just blur the background a little bit.
Can we also use for the applications here? Exact image.
Yes, yes. So currently there is a new type of model called SAM kind of model is there, no? So these are all like can do it. So in iPhone, if you just long press on one image, it just takes a sticker out of it.
Yes.
Yeah. So that's
Show those specific matching boxes. Here in our conversation, while we talked about
okay. So ChatGPT is better than Claude and Gemini. Uh, what is this? Oh, all this filters. So you can create some special effects. So it just segments the football player and you can add a glow around him. Samasa? Yes. Yes, yes. Yes.
But LLMs are still way more expensive.
Yeah. You know, yeah. You can't use it in Raspberry Pi kind of, yeah. That is another thing that you need to take into account.
It is a runway where you can edit the videos with the text to
Yeah.
This kind of text and you pull it with the scene. If you have taken the image or sort of one if you directly in different angles, it means different videos.
You can generate videos.
Runway.
So a lot of this Instagram Reels, YouTube Shorts, there are a lot of AI videos, right? It's very realistic.
Open hat, one
A lot of these old people, they don't know able to differentiate. And yeah, I see, right? Like a lot of AI videos are coming. They look very, very realistic. It looks very dangerous, right?
which is weird out of the
Mm.
to go to the internet, actually find all the images and create full-fledged video. Like,
Yeah.
if you use Amazon link, it will create the entire video. Yeah.
Yeah. I used it extensively for this interiors, in house interiors. ChatGPT, ChatGPT. We just put your 2D design, give some sort of colors and all those things. It gives very realistic renders. Yeah.
One model shows specifically for image.
Yeah.
There is a company Bangalore which is creating a tool for builders and buyers also. They can choose products where you want and how you want it.
Yeah.
So you put the layout. On that layout, you can put the products and see how it looks like.
VR, AR kind of.
Get the link.
Yeah. It has gone. The performance is very good actually. 2-3 years back, it was crap. Yeah. Okay. Let's wind up for this week. Let's complete this.